start. So it's a pleasure to be here to have another Bioconductor Developer Day or Forum. I think it has been like 2 or 3 years without one. And for me, when I joined these kind of forums, what's very helpful to have a plain discussion between developers to know how to develop packages and discuss how to implement these ideas on different packages I was working on at the moment. And recently I was approached by Wenjie about this Rust and how to implement Rust in Bioconductor. And as I already spoke a year ago already, I think with Josiah and other people about Rust, I thought it was a great idea to mix these topics and see if we could have a developer forum about Rust in bioinformatics at Bioconductor with our packages. So we decided to set up this, and the agenda, maybe you have read it already, but it's initially some discussion about how to implement or Rust with R, and then a little bit working more towards the bioinformatics and the biological question, or how it helps on Bioconductor, how it could help. Yeah. Having said that, I suppose there are no questions. This will be recorded and it will be posted on the Bioconductors forum channel. And then we can just check afterwards the recording if anyone has questions. And of course, I think that there are also the contact details of the participants that will be speaking. And also there is the Bioconductor Zulip chat to ask questions there or to the Bioconductor community. Yeah, I think, I don't know who will start speaking, but I give the floor to the speakers. Maybe Josiah, go ahead, please.
Yeah, I'm gonna start sharing some slides. Can you see it all right?
Yeah.
Cool. And as we go along, if you have any questions, feel free to pop them in the chat, and whoever of us is not speaking, we can do our best to answer them. And we'll have time at the end to have extra questions. We want to keep this a little bit brief because it's a forum. We don't want to be talking at you for like a whole hour, so we could have a bit of a conversation. So I think like first and foremost, I just want to say thank you for inviting us. I've been programming in R for like 10 years now, which is crazy to begin with. But Bioconductor has been like a background in like the R, my experience in R, and I've never been part of bioinformatics, so I've never actually had a reason to use it, but it's really nice that you've invited us here. And we're really excited to see how we can kind of collaborate. So I'll hand it over to Mossa to start, just introducing himself.
Yes. Hello, everyone. My name is Mossa. I'm from Denmark, and I am the maintainer of Extendar. I have a PhD in veterinary epidemiology, so I too am a bit far away from bioinformatics and Bioconductor. And I work as a postdoc at the University of Copenhagen. So that's me.
Yeah. And I am a senior product engineer at Esri. So if you all work in the geospatial space, you've probably heard of us and maybe think we're evil. But I'm a spatial statistician. So I think about, how points relate to other points and polygons work in that space and how we analyze them. At work, I spend a lot of my time building R packages to kind of interface between our online services and R. So that involves a lot of Rust actually behind the scenes to make sure that everything's fast and efficient. And Wenjie, if you wanted to introduce yourself here, totally can, but we can wait to use your time.
Yeah. So thank you, Josh. So I'm Wenjie. So I was postdoctor in Institute Curie, and next I'm moving to the Michigan for research scientist in the single cell sequencing. So my interest mainly focusing on the single cell experiments and data analysis. And I find the RAS is very powerful and for speed up the efficiency of the programming. So that's why I'm interested in that. And very happy that Mossa and Josh is willing to share the tools it developed and the R extend R so to the bioinformatics community. So I think it's very exciting.
All right, so maybe let's just start with like setting the ground level of what actually is Extendar. And the name really comes from what we're doing, which is extending R with Rust. So the main goal here is that we want to be able to include Rust into R-based packages, or R packages. So if you're building an R package, we want to be able to provide some of the functionality inside of that R package using compiled Rust code. So if you're familiar with RCPP and CPP11, it's kind of akin to that, where you can use RCPP or CPP11 to create highly performant R packages that use C++ under the hood. And this is an alternative because we're not using C++, but instead Rust. So that is our primary objective. And when we're thinking about Extender, we also have to think about like what Rust is. And honestly, I didn't know what Rust was until about 2 years ago. And it's a low-level language. So unlike R or Python, which are high-level languages, Rust is very close to the metal. So it's intended to be able to do a lot of like operating system level type stuff. And a lot of people over equivalent. Sorry, it's very early here over the West Coast. It's a modern day equivalent to C++. So people think about it as similar to that, but it has a lot of advantages over like traditional C or C++. And the one that you'll hear most about is that it's memory safe. I would say it's memory safer. We do a lot of things that are unsafe, but it's required, particularly with an extender. And more than anything, I think Rust is exceptionally developer friendly, which is why we're seeing it, kind of shoot to the moon. And it's one of the reasons why I'm able to actually write Rust. And one of the other things that we want to mention is that there's no default garbage collector. So languages like R and Go and other things have a garbage collector, which keep track of, objects as they accumulate in memory and release them as they're not needed. Rust doesn't have that. So you're only using the things that are actually available or need to be used at any one time. It's referred to as the borrow checker sometimes. It can cause a lot of pain for some people as they start, but you learn to love it. And I'm going to hand it over to Mossa here.
Yes, so when we started with playing around with Rust was a very good language for doing low-level software engineering, but it wasn't as prevalent in the scientific community. And now this has completely changed. So what you see here is the survey from the Rust user survey, and we have had consistently 10% of the cohort, let's say, using Rust for scientific computing. And this is a little bit important to keep in mind because as R developers, we might think that we are the users of Rust and want to implement things in Rust, but the other way around can also be true because there are Rust developers that create scientific computing algorithms and frameworks, and they would also want to present that work to the R communities. So yeah, that's my point here.
Awesome. And then also, I just want to indicate that even over this last year, we're seeing a pretty steady increase in growth in the scientific community of over 1%. So what actually is Extender comprised of? So Extender is actually just it's the project name, and it's comprised of many other things. The first thing that you may encounter is the R package called Extendar, or R Extender, which is a use this like R package. And we don't really assume that everyone's going to be an expert Rust developer and that they know the ins and outs of the Cargo CLI or other CLI tools. So we really want to be able to facilitate most of the interactions with Rust through R, because that's really the target audience that we're trying to work with here, are R developers like yourselves and us. So we have this R package, which will scaffold an R package for you that uses Rust. We can add dependencies through it. We can vendor dependencies through it, so on and so forth. And then on the Rust side of things, there's a crate called Extendar API. And this is really the core Rust library that people will encounter and work with. This has high-level wrappers around the RC C API, and it feels very Rust-like to work with. And this is really going to be most people's interface to the Extender project from the Rust side. Then underneath that is actually another library called extendr FFI, which is foreign function interface. So these are the raw C bindings to our C API. And this is what hopefully none of you will ever have to touch, but it's what extendr API is built upon. And then underneath it, we have the extendr engine, which is not actually used in building the R packages. Instead, what this lets us do is it lets us start an R process inside of Rust. So you can imagine that you're creating a CLI tool or some sort of binary or even a desktop application. You can start and call R from inside of that binary using the extendr engine and process the results as native Rust structs. And we've actually seen quite a bit of adoption. 16 is a small number, particularly when a good number of them are mine. But there are 16 packages on CRAN that are using extendr today. And as I've learned over this week while preparing for this talk, is there's a lot more on GitHub that we weren't even aware of, and people are using this, in their everyday work. And since about 2024, we've seen over 380,000 downloads of packages that are using extendr under the hood. And we can see that this is starting to tick upwards quite significantly in this new year, which is really, really exciting. And I think it's just going to prove that, like, hey, Rust and R works well together, and we're figuring out how to, work with CRAN in a way that's amenable for everyone. So next, I want to maybe talk about, why we chose Rust, or at least why I chose Rust. And this isn't really a technical reason, it's more of a personal preference. And I think the first thing is that Rust is exceptionally fast. Most things that you do, even if it's a super naive implementation, is going to be blazingly fast. And that's really nice when if writing code that may use nested for loops or things like that, or advanced iteration, to just have the basic implementation be really fast, and you can be confident that it's going to scale effectively. Secondly, I think one of the reasons why I've actually been able to learn Rust is that the compiler is very nice. So when you are debugging R code, there's not typically anything that tells you exactly where your code went wrong and how to fix it. But if we look at some of the compiler errors that we get from Rust, it tells us exactly what's wrong and even exactly how to fix it. And this is an exceptionally helpful thing as a new developer and even as an advanced developer using Rust. And because Rust is a strongly typed language, and because it knows where everything is used, refactoring your entire Rust codebase is actually not that difficult. It's easy enough to refactor. And here's a fun little poll I found on Reddit that, most people think refactoring with Rust is fairly easy. And the last thing I think I really want to mention is that I think choosing Rust is super important specifically for the scientific community, because if we write our core algorithms in Rust, we can really broaden our reach, right? We can say, hey, I have this core algorithm I've written in Rust, and I can use libraries like Pio3, extendr, and JLRS to create bindings to that core algorithm that's written in Rust. And that way, the developments or innovations that you make are not just siloed into your specific domain or your specific community. We can really expand the reach by being able to kind of create the core Rust library and bindings to each of those things. And lastly, I think it's really easy or fairly quick to pick up. So this is, I think, a poll from Google, which shows that most people can get up to speed or confident with Rust within, I think, 1 to 2 months. And that's not saying we're like the most expert Rust developers, but you feel confident to be able to write just like basic intermediate Rust. And I would go so far as to say that a little bit of skill goes a very, very long way when you're writing Rust code. So for example, here, if anyone saw my Cascadia R conference workshop material, this is kind of derived from that. This is an example of performing a geohash encoding. So this is embedding an X and Y coordinate in 2-dimensional space into a series of letters. Super important for my domain. So this is an example of a Rust function, which is being able to be used in R. So the first thing we see is this little attribute that says, hey, this is an extendr function. We're defining our function. This should feel similar to a lot of things in R. We just have the type annotations in the output. So we have an X and Y coordinate, which are floats, and the length in the output, and we're returning a string. Here we're creating what's called a struct or a structure. Think of it like an, I don't know, an S4 class, which is a coordinate, and then we're encoding our geohash. This alone is super powerful. We've now written a function that takes an X and Y coordinate and performs this geohash encoding. But now I can actually vectorize it with just a few more lines of code. So instead of returning a single string, we're returning a vector of strings. And what we're doing here is we're taking our vectors of X's and Y's and we're creating iterators from it. And now we're mapping over each element. So similar to using per map. And we're creating a coordinate and encoding that coordinate and collecting it into a vector. So with an addition of like 4 or 5 lines of code, we've taken that single geohash function and now it's a vectorized function, which is super important for the R community because we expect most things to be vectorized. Now, what's really cool is that when we've written this code, we are like 95% of the way of writing parallelized code. We only need 1 line to parallelize this. And this is saying, hey, I'm going to take this iterator and I'm going to convert it into a parallelized iterator. So I'm going to be able to chunk up this iterator into chunks of a minimum length of 1024. And now I'm going to leave the rest to do its work. And with those 2 additional lines of code, we've now written a parallelized function that can harness, all threads of your machine and, take whatever you've done on a single element and scale that out quite effectively. Now, when we were going through preparing this talk, I was searching for uses of extender on GitHub, and there are a lot specifically in bioinformatics, which we were quite impressed about. One thing was this library called WebGestaltR. Another is this CRAN package, Metaboticon, I think I'm pronouncing that correctly, which has an experimental Rust backend that you can install directly from GitHub and plug and play to use a different backend, which is much more efficient. Another package I've seen here is this MS-PredictR, which does something with peptides. I don't know what that is, but I'm sure many of you do. And ViewMaster, and also another thing that I found really interesting here is there's other tools that are being used across languages. So what I mentioned previously was that you have this Rust core algorithm with bindings in multiple languages. So what we can see here is there's another library called Philo2Vec, which has a core Rust library with bindings to R and Python. Another one that I've seen called Exxon, which is a database for bioinformatics, is a core written in Rust with library binding support in R and Python as well. And there's even more libraries that are already using Extender today for bioinformatics, which I found to be exceptionally cool. So now I'll pass it over to Mossa. Do you want to share your screen, or do you want me to keep sliding through it here?
Just keep going.
Okay.
So I thought I would instead of I thought I would bring a small example to explore and more concrete. Next slide, please. Right. So we have this small package called MDL, and what this our package does is that it takes a data frame and in return creates a model matrix for use in all sorts of statistical packages such as LM, GLM, and I think GLMNet is very prominently used in bioinformatics. Yes. And essentially what this does is that it takes variables and then it creates the design matrix. So here you see an example of this where this CYL is a factor, which means every level in the factor has to become a one hot encoded variable. And apparently this operation is very costly. It depends on how many variables you have and how long they are. We were able to, if you click on the next slide, we were able to implement a Rust-based algorithm that is 10 times faster than the default one in R, which is model.matrix. Now, performance is very important, but performance isn't everything, and it also depends on the use case. So I have experimented with this algorithm and the range. Can you go back one slide?
Yes, sorry.
With the range, it can perform, and essentially I get either 1.7 times faster than R or 11 times faster than R, dependent on the matrix, the data frame. But performance isn't everything. Sorry. Yeah, next slide. What's also important is that now we have such an implementation. It's 250 lines of code, of Rust code. There's a lot of other R code in the package to make it easier to use. The Rust code also includes the parallel processing of variables if that's desired. But what's really key here is that it's written in 100% safe code. And this means that, click one more. Yes, this means that any non-expert in Rust maintainer can go in and tweak MDL, and if it compiles, it works. They don't have to contact me and tell me whether or not their changes is correct. And actually, after I contributed the main Rust code, people have already changed it, and I haven't even heard of it. And that's a bit the powerful part of having Rust-based packages, that people confidently change things even though they are not experts in them. Yeah. So I just wanted to briefly mention a few things about our roadmap within the Extendar project. So it's all about developers. So we think Extendar is done more or less, or at least it's ready for prime time. And what we really need to do now is to ensure that using Rust in our packages is as easy as it can be. We have managed to get and keep packages on CRAN, and it's almost the majority of the time of the many extended contributors spent on that. And it would be nice if we could have a similar or even better user experience for Rust developers in Bioconductor. And it's also now time for us to improve our documentation, and we have also spent a lot of energy promoting both Rust and R and Extendar through presentations and workshop. And there's really, I mean, there's really many things in the Rust ecosystem now, even though it's very small, that would benefit R. So even if you come in as a person who doesn't want to write your own Rust library first and then a binding to R, there are many things in the Rust ecosystem that is just waiting to have a binding package in R written for them. And that's also a way to come in and start working with these things. So yes, this is also a call for more maintainers for Extendar, and no matter what part you really like, if it's the R part, the Rust part, the Extendar part, there are room for you as a user or as a developer. So please contact us.
Yeah.
Yes.
So go ahead.
Thank you for listening to us, and I think we probably need Wenjie's talk now, but we want to hear your questions, and let's have a discussion.
So
I mean,
later
feel free
I'll bring some examples. Maybe if you have questions about the conceptions, you should ask now.
Yeah, feel free to directly ask the questions here or raise your hand or react some way. Don't hesitate to ask anything. And for starters, I wanted to ask how difficult is to release a package on CRAN or Bioconductor with Rust? I mean, I heard over the years that it's difficult to release a package because the quality checks on our community are usually stronger or more detailed than other languages. And if you could share a little bit your experience with that.
I'll go first. So releasing a package on CRAN now is pretty painless. We've gone through a lot of like growing pains working with CRAN, and I think they've also gone through growing pains too. And we've, figured out how to build our packages or build Extendar and our extender in particular in a way that whenever you do build a new R package that uses Rust, it is compliant with all of CRAN's policies from the get-go. So if you do create a new R package using R extender based on the current release, the R package that you create will be CRAN compatible by default. Though if you do start using things like Rayon for parallelization and you put these in your example, that's on you, because anytime you have your code, it was like 8 seconds of system time, but it ran in 1 second, CRAN will get upset. But beyond that, it's not that difficult at all. You just need to document your code. You need to, vendor your packages. This is all documented. And you can always reach out to us in the Discord channel if you have questions, but it's pretty painless. It's only a tinge more painful than releasing a normal package.
Thanks. I see a question from Lucio, so go ahead.
Nice presentation, Josiah and Mossa. So yeah, just extending on that, the biggest pain point on CRUN is that, I'm trying to talk to someone that understands both CRUN and Bioconductor, is that on CRUN, the biggest pain point comes from how they build their build machines, that they just install the Rust toolchain from the package repositories, like from apt, from DNF, and then they have different versions of Rust running on different machines, and that limits what developers can use as the package that they can use, especially when you use Cargo, that is the package manager for Rust. But Rust, if you write Rust just pure Rust code, and Josiah has been doing that for a long time, much longer before Extender. Or if you just want to compile Rust, it's pretty straightforward. It's easier than C, because C don't have, like C++, you don't even have a package manager that works on CRUN, so it's pretty straightforward. But the main point for that discussion is that Bioconductor need to see how to actually implement the install the two chains in a nicer way than what CRUN does.
Yeah, so we did have some slides on this actually. I would like to say that if a Bioconductor is interested in adding Rust to their build machines, it's simply just a discussion on what the parameters should be, and there is solutions to every problem, right? So Rust, like Julia, is made so you can have many versions of the compiler installed simultaneously, and they would work with each other. So for instance, the reason why we call Rust programs for crates and not libraries, it's because Rust is very conservative, and any time it produces an output, it bundles up all the dependencies compiled in the current compiler you're using into the one unit that is, but it's not a library because it's not meant to be shared with other versions. So even if you have all the versions of Rust installed and you have many packages that are built with different compilers, they all work together. So the conservatism of not installing Rust by yourself on the build machine is not really supported by how Rust is meant to be used. But yeah.
I see a question on the chat, so I will read it from Todd. So it says, in RC++, I remember they discourage against, for example, using OpenMP directly, instead interfacing through RCPP parallel, because concurrent interaction with our objects can crash the program. Does Extender offer any recommendations about interacting with our objects in parallel? You want to take that question?
I'm going to give my non-technical answer here, and then Mossa has experimented with this a lot. So with Rust, there's these ideas of traits, which are like classes of behaviors that things can do in Rust. And the way that Extendar is written is that R objects or bindings to these R objects, which are SEXPs or whatever, we can't actually safely send those across threads. So Extender doesn't let you do that with R objects. So what you can do is you collect them into a vector or some other thing that is a Rust native structure, and then parallelizing that is inherently safe because what we're using is safe Rust code. So, but going through like the process of, how do we take R objects and not go through this process of like copying and cloning the memory space and being able to use that in parallel is another story that I'll probably let Mossa just extrapolate on a bit more.
Yes, so there are many. So this is a very core advantage of Rust when you want to write parallel and concurrent code. And we have Extender does provide some capabilities to manage these issues. And I think also the MDL package is an example of how I have demonstrated how to interact with R objects in parallel without breaking things or invalidating any invariants. But it also depends. Like R is used for many things, and it depends on what level of parallel computing you want. So, for instance, OpenMP is probably too big for a little algorithm you have where you want to divide a few numbers or encode a few things. And you in Rust you basically build these parallel jobs yourself, and you can control where invalid or where you ask in threads things from R that you shouldn't ask for, and this is much more easy to control in Rust than in other languages. So I think it's also like a different kind of conversation we need to have about it, depending on the use case and the parameters. I will not say more now. Thank you.
Yeah, as always, it's a balance between different constraints and considerations on programming. I have another question, maybe more on the developer side. So we said that it's very easy and it's blazing fast to develop, and also the line of codes are short. But when we need to interact between R and Rust, do we need to put the Rust code in the ints folder and call it from R in a special way? Or maybe this will be covered in the examples in the next section, which just a bit curious how to do that.
Yeah, so I think we have pretty much mimicked the user expectation of RCP. So there are functions where you can put raw Rust code in your R script and compile them, and then the function will be directly available to you. Like in RCP, this is possible. But also, if you implement it in more of a package setting, we generate all of the scaffolding for you after you write your Rust function. And then the R extender package, if you use its document function, all of the scaffolding is done. And then when you load the package, you have the Rust function available to you. The user guide and other resources we have released explain this in a lot more details, if you like.
Yeah,
Thanks,
I would
Mossa.
just say that it's a compiled language, so it uses the structure that's required or recommended by the R project, which is to use the SRC folder in an R package. And I think that's the recommended way of building anything with Extender. You can use the inline functions, but no guarantees there. It's just best for like prototyping stuff.
Any other question from anyone? Oh, yeah,
I
there's
will,
another one. Go
well,
ahead, Vincent.
I'm going to just jump in. Thank you very much for doing this. There's this issue that we face in Bioconductor that I refer to as a regulated repository concept. And it's been pretty important, I think, to the durability of the project that dependencies are controlled. R packages are the fundamental elements of a bioconductor ecosystem. And package declaration of dependency is permitted, but if you're going to have a package in Bioconductor, it depends on another Bioconductor package or on a CRAN package. You've mentioned that there are a great many applications in GitHub that are successfully using Rust. But I do think that the ephemeral nature of packages that are only in GitHub is a real problem for keeping an ecosystem usable by its user community. Another thing that we have dealt with in a way that I think is not so natural for folks who are, full-time developers is synchronizing Bioconductor to the current version of R. So these are two features of the Bioconductor ecosystem that I just wanted to check to see whether you've thought about these sorts of constraints and how they might affect thinking about developing in Rust for Bioconductor. I hope that's clear enough.
I think it is. So one thing to mention is package declaration, right? So if we're using Rust here, I'll see if I can share my screen actually. Let me move zoom out of the way so we don't see our own faces. So when we're developing Rust libraries, we have to have package declaration in the same way that you have a description file. And we do this using a file called cargo.toml, in which we explicitly define what our dependencies are and which versions they are. And moreover, these dependencies have dependencies, similar to how our packages have dependencies as well. And when you develop a package, there is an automatically generated file, or developer create, automatically generated file called a cargo.lock. And this enumerates every single package that is used through all recursive dependencies, what their dependencies are, the exact version, the checksum, and the place that it came from. We don't even have anything this clear in the R ecosystem, which I think we could benefit from. We have rm.lock files. We used to have packrat manifest.json files, but we don't have anything like this in the R ecosystem. But additionally, part of the problem, or part of what you're describing is that it's ephemeral. That's a thing that CRAN forces us to solve as well, in which we have this file for every package called a vendor.tar.xz. This requires that we take all of the exact versions of the libraries that are mentioned here, and we zip up their source code into a directory, which is unzipped at build time and compiled all together. So all the dependencies that you need to build this package are available here in an offline environment. The other thing that you mentioned, which is that there's this ephemeral nature to packages that are on GitHub, I think that's actually less of an indication of the developer or the tool than the community in which they're building it for. I think this is a problem that we as the R community kind of face, is that we put such a big barrier in front of developers to publish their tool. It is an exceptionally time-consuming and challenging thing to do to publish a package on CRAN. Particularly, I don't know how it is for Bioconductor, but I assume it's also tough. And then there's things like there's all these barriers that come into it. There's a big maintenance burden. Sometimes there are things in which, there's issues that arise that are no fault to your own, and your package will be removed, and you might not even be informed of it, so on and so forth. I think that is not an indication of the quality of the software that's developed. I think it's an indication on the community for which that we're developing and how hard it is to publish for it. I don't know. Those are my thoughts. They're not like extender official. That's just Josiah's, pontifications.
Thank you. Just a quick question about this vendor.tar.xz. That was something that became obligatory when working with CRAN. Did I hear that correctly?
Yes. But I would want to let Mossa add to that previous statement first if he has anything else to say.
Yeah, yes, I do. First of all, I would like to thank you, Vincent, for your question. I think it's a very important question. And I think we have, I mean, personally, and the other extender people, we have thought about this many, many times. So you are able to have GitHub hosted dependencies in a Rust package, but that is not the norm at all. What really happens is that all the packages and dependencies, they are published on something called crates.io, and there is a legal entity that is responsible for maintaining this package repository, and none of the pipeline as of version 1.70 of Rust deals with GitHub unnecessary by default. And I also think if I was to propose a policy for Bioconductor, I would also say if Rust packages should not depend on GitHub dependencies, because I think crates.io also has this requirement. You cannot publish on crates.io if you have a GitHub dependency. So exactly to eliminate the ephemeral nature of it. And also, Rust is used by many companies that have similar thoughts and similar constraints like Bioconductor would have. So there are facilities to take a subset of crates.io packages and make a custom registry for Bioconductor. So you guys, whenever you release Bioconductor, which is by every every 6 months, you can just update the registry and see if everything is still correct and intact before you push the new versions of Bioconductor. So, and all of these things, there are facilities for them. It's just, we should just have a conversation about it and build that infrastructure so everybody is happy. And there are many other problems that R and Pran and presumably Bioconductor have that are unique, but a lot of them are also common. And there are definitely solutions on the other side to our common problems. So that's what I would say.
Thanks a lot. Very informative.
I think we should make time for Wenjie to present now. We've been talking a while.
Yeah, it's what I wanted to say, that we can move now to more Bioconductor examples or core bioinformatics part of the discussion today. So Wenjie, whenever you're ready.
Yeah. So actually, it's exciting to have Mossa and Josiah here because they are creator of the package. And okay, just to share the screen. So at the beginning, so can you see my screen?
Yeah, we can see it.
Okay, great. So actually, I know Rust around 6 years ago. So during the COVID confinement, I chose Haskell, and because I appreciate the functional programming, which is similar to R. And that said, I used R for more than 12 years already. And then I found the Haskell is too slow, and then I start to touch the Rust. But unfortunately, so I cannot use Rust and R together. And just around half a year ago, I read a Twitter from Josiah, and then I learned the project Extend R and start to try it. So I'm going to share my story with R and Rust, and from another perspective. So I think any questions, technical questions or policy questions should go to the Josiah and the Mossa. I just sharing my experience of the R and the Rust as normal bioinformatician and with biological background. So here it goes. So how I began with Rust in R, maybe you ever tried it or not, but I think it's very easy to start and with Rust in R. Because thanks for the very well design of this Extend R package, so you can easily try the Rust in R in an interactive way. So you can define a Rust function. So this is one of the easiest one. Add two integers together in R just by typing. And then you can compile it. Yes, you can compile it in R. And then all the dependency will be installed and compile it. And therefore you can use it here. So by this way, so you can try, and at the beginning, so this is what I did. I tried and find it's quite easy. And it should be mentioned, so the default comparing is in a development mode. So it's not optimized. If you need optimized, you need to set profile to release. So therefore you can have better performance with the compiler optimized. So therefore you can try different way, and you can just ask for input of vector and output, and try to sum all the value in the vector and compile it again, and then so you can try to run it. So here, so we need to as integer. So you can run it, and so it's a very easy way to test it. But if you have more code to test, so you also can easily try to load Rust from the file. So here, so we can load Rust from the file at so here is a Rust file. So with the header, so if you used RCBP before, so you know you need to include rcbp.h. Here we need to include the extend R, and then so we can define the Rust function here, and also we can change the result, and we can ask the output a list. So it's quite convenient, and so then, so we will have the result as a list. So we can try it again. So now the result is list with the name of the Rust. And then, so this is how I try with the Rust. And if the file become bigger, so need more room, so we just create the files. And then, so about a very quick example in bioinformatics, which is ongoing. And I'm trying to create an app package to calculate the PSI for single-cell RNA sequencing. So if you are very familiar with RNA sequencing or transcriptome, so you know, so in our genome, so the gene is spliced, so which means when gene is transcribed, so intron will be removed and exon are joined. And the different combination of exon from one gene will have different protein sequence. And in order to measure this kind of alternative splicing, it's called alternative splicing. In order to measure it, so we can calculate the PSI index, the percentage spliced in, by dividing the spliced injection rate number to the total rate number. So in order to calculate this value, so we need to access to the GFF file, so which has a gene annotation, as well as a BAM file, which is binary. It can be indexed, so we can access a specific region of the genome. So the idea is to have the GFF bands and the gene ID and output the PSI values per event for all cells. And so the GFF file is easy to pass to process because it's text file. And the BAM file is binarized, and because we also need to random access. So one of the idea is to use HTS lib. So there is RC++ version of our HTS-lib in the bioconductor. But in order to use it, so we need to modify the make file, and also we need to read the C++ document in order to use it. And in Rust, so I find it's very easy, and also this is key point to make me feel exciting about the modern package management. And here, so I'm going to show you how I can use the HTS-lib in Rust in R. So it's very easy. So we just need to add a dependency, so which is Rust HTS-lib and the version of the library. Then we can run it. So by this way, we are going to comparing the code, the Rust code we have in the file. So in the Rust code, so we just to define a read BAM function, so which will read BAM, read from BAM file, one BAM file, and it will output a list object in R with reads chromosome locations and the reads position, mapped position, and the cigar, so which is necessary to calculate the PSI. Now the comparing is finished, so it's quite easy. So we don't need to modify the make file. So and we can just have the result. So we can run the read BAM file, and we can read the first 10 reads. So you can see we can have the chromosome ID and position of the reads and the cigar. So in order to build a package, so we need to use another way to run Rust in R. And it's also quite straightforward and easy, especially if you had no C++ before. So in order to create a package, so first we need to run the use sys to create normal R package. Then in order to use Rust in the R package, we only need to run one line, the R extend R, use extend R. So by running this, so a folder will be added. So in the R package, so which will be the src, and it will include all the files, scaffold needed to add Rust code. And once we run the R extend R use extend R, so we can add files in the Rust, so in the src folder under the Rust folder. And by doing that, so we can try to create an R package to read the BAM file from single cell sequencing, and then so calculate the PSI. So here is a quick example. So I just try to run it. So we don't need to do the preparing before. So here it's just in like a normal R package developing way. So we set current director, and by running the document, it's very similar to the development package document function. So it will load the Rust function, and then so we can load the GFF, so which is the function we defined. So in Rust, try to pass the GFF files. Once it's done, so we can try to calculate the PSI. Here is the BAM files. So this is a small example with 20 BAMs, and then we can calculate the PSI. Actually, it's very fast. So you can see in order to open the BAM files, to get the BAM file handles, it will take even longer than get reads file from BAM and calculating the PSI. And here, so for me, so it's very fast, and because so we can do the parallel easily. So I can show you the parallel, and so as Josh said, so in R, it's very, so in the Rust, it's very easy to do the parallel. Here is a parallel function. So we have the bound file list. So I can parallel the process for each BAM and just add the PAR iterate. And also, so in the Rust R, so we also have, because Rust is a typing language, and by using this, so those typing, so you can see, so in the file, we have a lot of structure design defined. So it defines the region of the exon or exon or intron. So it can help us to easily understand the code after a while, because it's like my external brain. So for me, so another things, it's very easy for me to use Rust for bioinformatics task is external so it's external point. So here, so loading the GFF will take a lot of times, and in order to use GFF information in the Rust again, so I try to output external point, so which will be a binary point, a data in the R, and so it's for Rust. And so in order to Rust to reuse again, so we don't need to transmit to change the format of the data, and the Rust can directly use it easily. So the last thing is the extend R. So it's very easy to handle the dependencies. So actually, so if we need another package, so Rust package, we just need to define it here, and so in the cargo POMO, and so we also can define the version of the dependency, and so in order to install the HTS lib, and so we don't need to configure to configuring the make files, and so it's quite straightforward to take advantage of the Rust package systems, and that's the demo I want to show today.
Thank you very much, Wenjie, and everyone on this talk. All the speakers, it was a great job. I think we have 3 minutes left for some last questions. I think that especially this last example was very helpful to see how it's used and how one developer could use Rust with an R package. But maybe there are some questions. Come on, don't be shy. No issue on the chat. Let me check. No. I have one question. When you compare the R share lib with the Rust one, I mean, there is definitely a speed difference and also how it's linked. But in terms of, I'm not sure if to say like developer time or mental processing time. I mean, sometimes, yeah, code needs to be faster if it's executed many times. That's maybe on this example shows, but other times a lot of time is spent on models and or thinking about how code works and reviewing it. So it's also easy to do it. If not, don't answer. I think Justin has wanted to ask or maybe answered in my question.
Yeah. So for me, the Rust is not my first language. My first language is R, of course. So it's second language. So I also need to search the menu, Google or ChatGPT for some functions. And I think one of the key, key feature of the extend R package, the linker between R and Rust, is I can do very quick prototyping because I can just run code in R, and also I don't need to create a package or library to try it or compile it into binary and try it in shell. So I can try it, quickly. So in an interactive way, so which can save the time. And also for long-term maintenance, because the Rust has a typing system, actually it's much easier to read my, historical code than R. Sometimes when I write R quickly and sometimes and come back to understand, so what's the data structure in a variable. But in Rust, it's quite easy. And also it takes advantage of the text editor because it's a static language. So the Rust has a Rust analytic. So it can help you to understand your code, give you the types of the code. Also, it can give you suggestions and when you writing code. So in that way, it can be easier.
Many thanks. Justin, I think you wanted.
Yeah, great talk, everyone. Thank you for like organizing and bringing these two communities together. I have a question that's maybe more geared towards the bioconductor people in terms of the code review process. So if there was a package that did include Rust code, is there any concern about like how that might affect the code review in terms of having people view Rust code as a part of the bioinformatics package?
I would say definitely, we would need new reviewers who are well-versed in Rust to help maintain the practice. And, I'm not pessimistic about that. Seems like you have an active community. So finding people who would take responsibility for that may not be difficult. But I think the two hurdles we have to clear are first understanding how portable development of packages in the build system can be accomplished with Rust. What is the tool chain? Where are the bumps? And then the other is, what are the package standards, let's say, that should be met in order for a Rust-dependent package to come into the ecosystem. So I think it's quite a bit of work for a very limited core to adopt a new technology like this. But, we are a community, and I'd like us to, huddle together and come up with a solution that's satisfactory. I'm going to have to jump on another call, but I really appreciate this. I took a lot of notes, and I hope, Wenjie, if your code is in a repo, we could try it out. I'll definitely take a whack at that. Thanks, everybody. Gonna have to hit the road.
Yeah, thanks, Vincent, for joining, and everyone. I think we are over the estimated hour. Many thanks all the speakers. And I don't know if anyone wants to keep, but if you have time, the speakers, we can keep if there are more questions. Keep going. But
I can hang out for 10 more minutes.
Yeah, now we just need more questions. Not, we can wrap it up here and bring these questions offline or to other places or to other meetings. I also maybe wanted to comment also on the question about reviewing packages with Rust. I think Run doesn't review Rust code. Bioconductor does more thoroughly analysis or review of code, even R code. So yeah, the concern about the quality of code added to Bioconductor, it's higher. But then there is also less checks once the package is added to Bioconductor, because then the repository is directly on Bioconductor servers currently. And so developer, the maintainer, can directly push the code without any review to the package that will be used to build the next release. So if one wanted to be a little bit sneaky, could try to like provide initial way without just our code and then just submit next version with the Rust code and see what happens. You'd have 6 months to fix everything and see what triggers that, and you can always revert back. But yeah,
I was just gonna suggest that like I see that there's like a need for reviewing code. I'm just curious as like at least extender, right? We create our functions. So in my perspective, what benefit does reviewing the underlying Rust code have other than like checking the validity of like, I don't know, your math or something? But at the end of the day, you're still generating R functions. So shouldn't you be reviewing the R functions and the R code that's developed?
I think maybe part of the concern is that Rust is a low-level language. So there might be, I don't know if there's any malicious bad actors, but I think when you get to deal with like low-level languages, some people might be concerned about if there is a system call going on trying to access like other directories or other files or something like that. But more or less you are right. It is Extender is going to be creating R functions anyway. So I think generally the code review at Bioconductor usually is just confirming that they are using the same coding style in terms of S4 classes. They're not like overwriting anything that's already an ecosystem with like namespacing issue conflicts. However, I'm sure there's someone in Bioconductor that's not myself, what I'm more concerned about, like what is our underlying Rust code doing.
Yeah, on Bioconductor, and reviews are open, so anyone can comment on anything, any package submission. And so, yeah, sometimes people chime in and suggest a different class completely or different structure to address some concern or say, okay, you are spending a lot of time to develop something while there is a solution already implemented on the ecosystem.
Yeah, about that, well, one of the main concerns with compiling the language, especially coming from the R core itself, was the interaction with the C API specifically. But that's something that R core have worked a lot in the last 2 releases to minimize the official APIs that are exposed. So this is already something that is on the works, and our extended work pretty well with that.
Yeah, that's actually an interesting thing too. They like literally check the symbols that are used that are like generated by the compiled binary, and it checks like there's a list of bad things that can't be incorporated in there. And we had to go the work of making sure that all those symbols are fine. So if you're inheriting the R command check, which I suspect you are, you're going to get the same benefits. But I also just wanted to like go back to what Justin was saying. I'm just probably not the place to have this conversation, but like if you're reviewing the R code for Bioconductor, and Bioconductor is, if I understand from this conversation, can incorporate CRAN packages, are you also reviewing the source of the dependencies that you're using? Okay, so like the bad actor stuff can easily come from CRAN, I think too, right? Like, so I think that's like an unfair comparison in that regard.
Yeah,
Just putting that out there.
No, you're definitely right. From my experience, I think they only review what's submitted in the package, not necessarily the dependencies. As to my knowledge, but generally I forgot what I was going to say next. I know like certain code, depending on what the code is doing, like, okay, so the main concern being that we just need people that can actually review Rust code in Bioconductor, because you can have an entire R package that only exports Rust functions, and all the actual work under the hood is being done by Rust. So
yeah, to bring it a bit closer to Josiah's understanding, that Bioconductor, they freeze all the package at some point. When they do that release, they actually release like what they call the Bioconductor version 3.20. It's going to be like one totally frozen version of all the dependencies of everything. So this is really relevant for the Bioconductor, and you guys already have the mechanism through vendoring the dependencies through, but the actual part of the gatekeeping on actually reviewing, yeah, this is totally arbitrary. They just bring someone that says, oh, this is very, it's almost like a paper review, like, oh, this is important for the scientific community or not, you know, you're using the classes correctly. So there is no point, and that also comes from the past where most of the packages don't even have tests or don't even. What the Bioconductor needs to do is actually starting enforcing, having proper tests, proper examples. Those are things that are better on Chrome, but still really loose, instead of just trying to keep scientific merit or not.
So something relevant, Maria Doyle, it's the community manager from Bioconductor, suggested to have a Rust channel. Oh, maybe I wasn't sure if you could connect and speak for yourself.
I'm sorry I missed the beginning. I managed to get here for the end of it. Thanks, Lewis, for organizing. Yes, I just suggested I could make a channel if you want to continue, because it seems like there's been a lot of good discussion and a great turnout here. So I'll make that now, that channel.
This is a major win.
And never try to install Rust through apt-get, please.
Too late. I already tried.
And it broke LLVM for you, probably.
Let's see what happens in the future.
So how should we install Rust?
It's a big.
I always say it's the second easiest language to install after R. And there you go. If you're on a Mac machine, it's super simple. Windows is a little bit more challenging, but it's still pretty straightforward.
On Ubuntu?
Even easier. You just copy
Yeah.
that script and you're good.
What
Yes,
do you call?
basically the recommended way is not depending on the main package manager, is through you download their own to Shane, but their own to Shane depends on GCC or other things that are recommended. But especially cargo, the tool cargo, if you want to build the package manager, shouldn't be the one distributed by the package managers, especially for the long-term support versions of OSs. And that's the problem we have on CRAN right now.
Well, I don't want to go into CRAN right now to discuss issues with CRAN.
Well, I think that it's important to have that discussion, because you need to have alignment, right, on what's done through CRAN and Bioconductor. But a few things were approached in the wrong way on how CRAN implemented the Rust support. And our Bioconductor has the opportunity to do it in a different way. But at the same time, we don't want to be in a completely different environment than what's used for building CRAN packages. So this is exactly a very important discussion to have.
Yeah, I think it's important also to know that we are firstly R people, we are R users, we love R, and Rust is a nice thing, in a nice addition to R. So of course we still want both CRAN and Bioconductor to have an easy time and a robust experience overall. But I am very happy that the conversation with the Bioconductor developers was so easy to initiate, and I do see it working out almost painless if we can just coordinate a little bit.
Yeah, I mean, I've been talking with some CRAN people, but each topic requires a lot of time, and especially a topic like Rust, installing Rust on the different machines and how they are managed inside CRAN. Yeah, because Bioconductor, it's more centralized to the Bioconductor core team, and the CRAN core team, it's less homogeneous. So it's much more difficult to coordinate and make decisions and unify this. But maybe we're working through Bioconductor, we can polish a little bit the pull request on the R develop our source code to fix some of the checks that are done by our command check, and start from there with more positive and engaging point that it's more attractive to CRAN and to our core, and then work from there to try to change the way that it's installed and how it's done on CRAN. But let's see. Let's say that it takes longer, even for just our code. It takes longer to get things done. Also because the availability and time they dedicate, they review a lot more code. They check a lot more things or different things than on Bioconductor, so they are spread more thin, and then it makes more difficult to work on these hard and complex issues as Rust.
And just to make sure that there is nothing wrong with the situation on CRAN right now. CRAN supports, like, if you write an R package with RxExtender, you can submit it to CRAN tomorrow. The only situation is that, for example, they have on the tool, they install different versions of the toolchain on their federal machines, different version of the toolchain on boot, and that's the problem. Even if you install for the package, but you are able to standardize, all the Linux machines are going to have the same version. That would be enough, you know. Because the problem is just how they handle even Linux itself is not straightforward. Yeah.
I think
Louis,
that, yeah.
Go ahead. Go ahead, Luis.
So part of the difference between machines is because each machine is managed by a different person. So they manage things differently. And so that's how it is. And from outside, and we cannot say how to do things. And even from inside, it's difficult to say how do you operate your computer. So that's why it requires to be more tactful and with a lot of patience and good endeavors. Do not start like requesting or imposing things, because then we get to a confrontation point, and that doesn't lead to positive outcomes for any one of us. I mean, they burn out, we burn out, the Rust doesn't work, the package don't build, and yeah. So yeah, even if it takes longer and it's difficult, it's very hard to change these kind of things at the moment. You were going to say something, RB?
Yeah, Luis, I was going to ask you if you've heard of any plans to, have the R configure script try to detect the Rust compiler, like they do with, other compilers, with C compiler, C++ compiler, Objective-C, try to detect Java. Are there plans to do something with Rust?
No, but
sorry.
Go ahead, Josiah.
Sorry, continue.
I haven't heard anything from them, and I haven't kept track of their source code, but I don't think I haven't seen anything on the news about that. But at least from the CRAN point of view, or from Kurt, they are focusing on other things currently. And I'm not sure, but maybe approaching them with a solution or a discussion about, okay, we have some script that could help to detect the Rust installation and configure better, would be a nice next step to say, okay, we want this to work better for yourself, to be more maintainable, and also for ourselves that we can use use things differently. Maybe they will appreciate, because I'm not sure if our core members are fluent on Rust, and maybe that's also why they are a little bit more reluctant or hesitant to make changes.
Yeah, that makes sense.
Yeah, the way they approach that is having cargo installed on the machine. That's just it. The problem right now is just they have different versions of cargo in each machine. If you're able to have cargo on the same version, cargo deals with all the Rust C, the compiler itself. Yeah.
Just to make sure I'm tracking, y'all are talking about the configure script for building R from source. Okay.
Yeah, that's what I was.
Okay, because
Yeah.
we have a configure script for extender packages for doing exactly that, but not for the R source.
I see.
Yeah, moving or trying to modify that for the Rust specific code could be helpful for our core members. And it's not just the current people that could look into that. So there might be more ways or more hands to try to work on that. But at the same time, I'm sure that the current people will be looking into what's being done if R it's being open or modified to use different compilers or different things from the installed source.
In my free time, I maintain Extendar, and in my extra free time, I try to look into the R source and try to mimic the behavior of the Rust compiler without cargo to how they use the C compiler and the configuration scripts. And there are some progress on that. So I have some project where I produce exactly the same object files that the R packages really like to have from C code and process them. There are definitely ways to accomplish all of these things, but no one is asking or starting the conversation. So it's just, it's just, it's a hobby.
The way that our core operates, they usually don't engage like saying, okay, we are going to work on this. Anyone that wants to volunteer, it's happy, join us. So they start doing, and then it's their responsibility to do things, and they take the decisions. And only afterwards, let's say they are a little bit more open to modification or from feedback from the community. But at the same time, if you start the conversation and they are interested, they are usually also open. But it's not so common to have like a common ground and our core members and outsiders speaking on almost equal terms on the same features. I think I have seen that on the last 10 years very few times, just with S7, sorry, and with very few other features. But I mean, if they start working and they say explicitly so in email or a bug report or whatever, you can usually engage with that core person to continue and develop, and I wouldn't say influence, but to give your feedback and your opinion on how to further continue that development or that enhancement. But we are running 20 minutes past the hour we said we should finish. And although it's very interesting, maybe we should, maybe we can discuss this in a separate meeting with less people, or just have another meeting in a couple of months, or I don't know, in a year, and see how far we have gone in this year.
Yes, I'm very thankful that we had this opportunity, and if anybody wants to engage with us, we all almost live and dine and everything in the Extendar Discord. So you can always get hold of us there. And I will also engage with the Rust channel on Zulip. And please, let's start the conversation. It wouldn't be immediate, but there's potential.
It's great to hear, and let's see and keep the channels open to collaborate. Thank you very much, everyone that attended, and the few that are still here. Thank you very much for all the questions and discussions and feedback.